All right. Yeah, as you can see, and as Vijay told, my talk is about changed package analysis for faster continuous integration in monorepos. So let's get into it. First, a little bit about myself. I'm Dorian de Koning. I work as a tribe lead DevOps. So we have these 3 tribes: the backend, DevOps tribe. I'm the tribe lead of the DevOps tribe. I've been working at Weave for 5.5 years now. And before that, I got my master's degree at Delft. All right, so first of all, I'll give a short introduction into the problem that we had, as well as some other possible solutions that we considered that didn't work for us. Then divided up in 2 parts, so handling changes to internal packages and handling changes to external dependencies. Because I'll go into it a little bit later, but there's some challenges in the second part. And then I'll give you a short example on what it looks like in our CI. So, first of all, what is the problem actually? So at Weave, we do projects for other clients, and we work in a structure where we have monorepos with a microservice architecture design. So at some point we had a project with 40, 45 microservices, 40, 45 cron jobs, something like that, and in a monorepo. So if someone made a change, then we had to test, lint, build Docker containers, deploy everything. So the pipelines then for merge requests took about 40 minutes, and then the deploy pipeline took another 30, 40 minutes. So that's, you all know that it's no fun waiting for that, and you have to context switch, stuff like that. So we try to identify what are the main bottlenecks. And the goal was to get the pipeline time for merge requests below 5 minutes, and for deploy 5 to 10, because that's going to wait a little bit longer for that. So the main problem we identified was that we were building, linting, testing everything. Mainly the test suite took 20 to 25 minutes. And so we said, like, well, what can we do for that? But before I go into a little bit more detail, that I want to say that this presentation, so it's about change package analysis for monorepos, microservice architecture. You're maybe not using that, but I think there's still some concepts in here that can be relevant for just understanding how Go works or how to optimize other build steps. So bear with me. And on the other end, if you're really into Go, concepts might be familiar already. But yeah, so we started looking for solutions to speed up our CI. The 40 minutes we're actually already using the Go cache. So we already used the build cache, and we already used the test cache. The problem with that is that the build cache grew very big. So gzipped, it was about 10 gigabytes at some point. So yeah, and we use Kubernetes runners. So every time we started the CI job, we had to download the whole cache, it had to extract it, and then run the job. And then actually running the test took 15 seconds, and the rest of the job took 20 seconds to decompress and compress it and upload it again. And besides that, it costs a lot of network traffic, still a lot of compute resources. So that was not really a viable option. Another option is, of course, just to do a git diff and then rebuild the microservices that have changed. Microservices depend on each other, might import client package, you might have shared packages. If one of those changes, are you still going to rebuild everything? That's also not an ideal solution. So then we started looking at available tools. One that we encountered was GTA by DigitalOcean. And that's a tool that actually checks which packages have changed, and then from a specific Git rep. And then it outputs a list with all the packages that might have changed based on that. The thing is, though, that DigitalOcean uses vendoring for all the repositories. So you have to push all your dependencies in your Git repository, which brings along a whole different set of problems. So we didn't want to do that. It's some contact with them, and we took a couple of concepts from their tool, and we built our own tool to do something similar for repositories where you don't vendor everything and you use Go mod instead of dep. So, like I said, we can divide it in two parts. So the first part is changing internal packages. So those are packages that are actually in your repository as a Go file or a directory. And the second part I'll go into later is dependencies on external packages that are in your Go mod. So the first part actually consists of 4 pretty simple steps. The first one is just listing all the packages in your repository. As with everything, the Go toolchain, all the compiler steps, all the tools that it uses are also exposed via a Go package, which we can really easily use. So there is the tools packages package, where you can give a path to and specify, like we say here, I want the name of all the packages in there. I want all the file paths. I want for every package, I want to see what packages it imports. And I want some information about the Go module. So that's pretty simple. So then we have a list. Basically, it's actually some kind of graph because you have all these packages. And for every package, you can see which other packages it imports. And by the way, I've added some code on the slides. I won't go into detail with it. They'll probably get uploaded to the Meetup page, so you can look at it or not. So then the second step is also pretty simple again. We just do a git diff with the ref we want to compare it against. It just outputs a list of all the changed files. Here for the purpose of this presentation, I don't consider some of the edge cases, so we just look at Go files, so not C files, not other kinds of files that might want to trigger a test or a new deployment for. So this returns a list of files, and then we convert those using the package from the previous step. We convert those actually to packages because the mapping might not be it is one-to-one, but the directory might not be the actual package name, of course. So yeah, then we have all the packages that have changed. We have a list of all the actual packages with the package that they import. So we can represent this or visualize this as some kind of graph. You're probably all familiar with it. So here in this example, we have package A that imports B, B imports C and D, and those import E again. But actually, these arrows are the wrong way around because this package D imports E. But if we want to do some analysis on if we change D, what packages we need to rebuild, we need to have the arrows the other way around. So we actually built an adjacency list representation, which with the imports the other way around, so imported by instead of imports. We store that as a map with the package name and in a list of all the other packages it imports for easy lookup. So then you can see that for package E, it's imported by C and D, D is imported by B, etc., etc. So then the fourth and final step would be to just do a breadth first search on this map. So in a breadth first search, most of you are probably familiar with it, but you have a queue with with your starting points basically, and then from those starting points you traverse the graph and try to find all the other nodes that you can find via those nodes. I actually see the turn around the arrows again. So imagine that they're the other way around. So what we can do, we can fill this queue with the output of the git diff or those packages, and then just every time pop the first item of the queue, mark it as changed, and then check which packages it's imported by, add those to the queue as well, and we can do that until the queue is empty. And it actually, so for, if we, in this example, say we make a change to C, we add C to the queue, it's imported by B, so B gets changed and A gets changed. We know that we have to rebuild these 3 packages and test these 3 packages and not rebuild E and D. So that's actually 4 very simple steps, I'd say, for just checking which packages you need to do. You can do this in 100 lines of code. But there's one thing, it doesn't take into account package updates to packages that are not in your repository. So even if you have a monorepo, you have packages in your Go mod, for example, that you import. Here's some code that I'll skip. You can maybe look at it. So yeah, there are updates to dependencies at some point, probably. What can we do then? Shall we just rebuild everything, say, okay, one dependency change that might only be used in one of the microservices, and then just don't care, rebuild everything, test everything? No, that's not ideal. Another solution we considered is having a Go mod for every microservice, but that makes dependency management a pain in the ass. Of course, if you want to update a dependency, you have to update 40 microservices for the other things, and keeping it in check is also inter-microservice dependencies is also a pain. So we don't do that. What we actually can do is just maybe take a diff of the Go mod, take a diff of the other Go mod, then see which packages changed, right? There's a problem with that, because in Go there's a concept of version selection. So okay, let's consider this case. We have a main package which actually imports A and B. There's a couple different versions of each, and those import C. So then package A imports C1.1 and B imports C1.1. So then it's pretty easy. The compiler figures it out in a deterministic way, and it builds all the code with C1.1. Okay, but what happens in this case? So in this case, we bump the dependency version of B to 1.3, which imports C1.2. What package would the compiler use now to update it? Anyone have an idea? I heard someone say both. Someone else? Okay, so we actually can't use both because if you have a function in A that returns a specific type, we have a function in B that returns that same type but from a different version that might not be compatible if we both use them in main. So therefore there's the concept of minimal version selection. So then the compiler checks out the minimal version that's needed for all the packages. So then it would actually build A 1.2 with C1.2 and B 1.3 with C1.2 as well, even though A 1.2 specifies that it has C1.2 in the Go mod. So this makes changing the packages or checking which packages we need to rebuild a little bit more complex. Or maybe not, because Go just exports this tooling. We can just call a function that exports. We don't have to implement this ourselves. We can reuse the same function that's used by golist-mall, which just outputs a list of all the versions that are actually used for building. So those are not the versions that are in the Go mod. Then, yeah, we compare those, and if one of those changes, we mark them, we extend the graph from the first part with the external packages, and we mark them as changed as well. And we can just go to do the same reverse search over them and rebuild or find the changed packages. So I have a little example. In our CI, it looks something like this. So this is a pipeline. I just took a screenshot of it. Someone changed the dependency on the Prometheus package, and this is in the repository for the microservices. I'm not sure if you all can read it, but the Prometheus package is then used in the user service, and the invoice service imports the gRPC client of the user service. So then it prints, I need to change the invoice and the user service. So we only test to rebuild those and deploy those. We can leave the rest alone. So some final remarks. Might have thought of them already, from how do you handle, for example, build tags, how do you handle non-Go files. I haven't gone into those, but maybe afterwards, if you're curious, you can come to me or just send me a message. And another interesting thing is, where we also build a tool for, is merging the code coverage, because we do want to have the code coverage for the whole code base after you made some changes. So yeah, if you're interested in minimal version selection, there's a research paper on that, which Go-based its implementation on. The tool is not yet open source. We're planning to do that somewhere in the next week, and will be on github.com/weavedev. Yeah, that's it. So if you like this kind of stuff, or just Go in general, like I said, I work at Weave. We're a company of 30-ish developers. We do projects for other companies. And in these tribes that I talked about earlier, everyone gets a dedicated amount of time to work on stuff like this. It can also be in DevOps or front end. We have dedicated time to work on this. So if that's something you might like, come to me, come to Lisa, or send an email to info@weave. Buy for a cup of coffee, maybe something. That's for everyone actually, not even also if you're not interested. But yeah. Are there any questions?